Welcome to MathTopia Academy. My name is Harika, and today I'll be solving questions 21 to 30 in the 2026 Math Kangaroo Level 7 to 8 competition. A shape is made from 5 touching squares with areas 1 square meter, 4 square meters, 9 square meters, 16 square meters, and 25 square meters, arranged in some order so that their bases all lie on a common line. Point A is a vertex of the leftmost square. Vihan cuts the shape along the line AB, which is parallel to CD. What is the area of the remaining shape as shown? Let's take a closer look at this diagram first, because this is the main part of the entire question. Alright, so we were given the areas of the squares. And based on the scale in this diagram, we can tell that probably the largest square over here has the area of 25 square meters because that is the biggest area given. So we can infer that this side length is 5. Similarly, for other squares, we can tell this is 4, this is 3, this is 2, and the smallest one is 1. Okay, now we have to find the area of this entire shaded diagram. We were told that there was one base, a common line, in which all of the squares met initially before the cut. And then we can draw this line over here to form a right triangle. That is the hypotenuse. How can we use this triangle? Since we can't find the area of the shaded triangle, we can subtract the area of this from the total area of all the squares before the cut was made. So, let's find the base of this triangle. The base is just the sum of the side lengths because 4, 2, 3, 1, 5 add up to that segment. So that is just 1 plus 2 plus 3 plus 4 plus 5, which is 15 meters. That is the base of the triangle. Now let's look at the height of the triangle. Fortunately, we are given that this square is right over here in the diagram, which means that this corresponds. Therefore, the height of our triangle is 1 meter. So now we can calculate the area of the triangle. Half times 15 times 1 is 7.5 square meters. We must subtract this value from the total area of all the squares before the cut, which is basically just the sum of those squares. So that would be 1 plus 4 plus 9 plus 16 plus 25, which is 55 square meters. Subtracting gives 55 minus 7.5 equals 47.5 square meters, which is D in our options. I have 2 old watches, my grandfather's and my father's. My grandfather's watch loses 5 minutes every hour, and my father's watch gains 5 minutes every hour. Yesterday, I set both watches to the correct time at 9 p.m. When I woke up the next morning, my grandfather's watch showed 8 a.m. What time my father's watch show at the moment? So we take the most important information here. Loses 5 minutes every hour, gains 5 minutes every hour. The correct time was 9 p.m. and then later it showed 8 a.m. and the grandfather's one was the one that did this. Okay, based on this information here, in the grandfather's watch, there is 55 minutes in every hour. Based on this, in the father's watch, there is 65 minutes in an hour. From 9 p.m. to 8 a.m., there were 11 hours. And we are asked to find how many hours were passed and what time it was on the father's watch for this given information. Let's write a proportion here. 11 hours over 55 minutes for every hour equals n hours for 65 minutes in an hour. Let's solve this. 11 times 65 over 55, which gives 13 hours. What is 13 hours after 9 p.m.? It is 10 a.m. So this was the time that was on the father's watch at that moment. The rectangle shown is divided into 6 smaller rectangles. The areas of 5 of them are given. What is the area of the 6th rectangle? Let's look at these two areas over here, 24 and 12. This means that this side length must be a factor of both 24 and 12. Let's make an educated guess and say that this is 6. If this is 6, this is 4, this is 2. If this is 2, then that is 9, that is 1, that is 3, 4 minus 1, 3, that is 14. Let's draw a line there just to make things a little easier. And then this part over here would be 5 because 14 minus 9, notice here, is 5. That means this is 5. 2 plus 1 is 3. This is 3. So 5 times 3 equals 15. So our answer is B. Anna, B, and Silly went to a stationery store to buy pens and rulers. Each of them bought exactly 10 items in total. Anna bought twice as many pens as the number of rulers Silly bought. B bought twice as many pens as the number of rulers Anna bought. Altogether, the girls bought an even number of rulers. How many pens did B buy? We're given that the girls together bought an even number of rulers, which means all of them bought an even number of rulers each, or 2 of them were odd and 1 was even. Let's take the easier case that all of them are even. So if the number of rulers Anna bought was even, the number of pens B buys would be twice a multiple of 2, which means it's a multiple of 4. That leaves the options 4 and 8 for this case. Let's look at the case 4. The number of pens B buys would be 4. BR would be 6. AR would be 2. AP would be 8. CR would be 4. And CP would be 6. Because this is a valid system, our answer, number of pens B buys, would be 4. Triangle A prime, B, C prime is obtained by rotating triangle ABC about vertex B. Points C, A prime, and C prime are collinear, and points A, B, and C prime are collinear. If angle BCA measures 15 degrees, what is the measure of angle BAC? Let's take a look at this diagram. So because it was a rotation and rigid motions do not change the figure inherently, this side is equal to this side. This side is equal to this side. And this side is equal to this side. Same thing for the angles. So we also notice that triangle CBC prime is an isosceles triangle because these two sides are equal. This means that whatever this angle is too. Based on rigid motions, we know that this angle is 15 degrees because this angle is corresponding. So that means this is also 15 degrees. For a triangle with angles 15 degrees, 15 degrees, this angle would be 180 minus 30 equals 150 degrees. So this angle over here would be 150 degrees. Okay, based on that, we know that this angle over here would be 30 degrees because this angle and the 150 angle are supplementary. 180 minus 150 is 30. If this is 30, then this angle, the angle we want to find, BAC, would be 180 minus 15 minus 30 equals 135 degrees. So our answer would be 15 minus 30 equals 135 degrees. So our answer would be D. A large cube with side length 4 is made up of smaller cubes with side length 1. What is the smallest number of small cubes that must be removed so that the surface area of the remaining shape is increased by 50% compared to the original cube? So since we have a cube with side length 4, this means it's a 4 by 4 by 4 cube with 64 cubes. It has a surface area of 96 and we have to increase by 50%. So we basically want to add plus 48. In order to remove the fewest number of total cubes, we have to make sure we target the cubes that give us the biggest or surface area boost. So notice that if we took an internal cube that's like completely hidden, we would add plus 6 to our area because it would expose 6 new inside faces with no outside faces to begin with. And if we removed face center cubes that are like flat on the surface and not corner cubes or inside cubes, and we can add plus 4 to the area because we lose one outside face but expose 5 new inside faces. So our goal in this plus 48 is to max out our 6s. So in our 4x4x4 cube, we have 2x2x2 internal cube, which is 8 internal cubes. So we can select half of these 4 cubes in order to make sure that they don't touch each other and accidentally change our number of plus 48. So through the internal cubes, we get 4 times 6 equals 24. 24 is done. So now in our remaining, we have plus 24 to cover up with the plus 4s of the face side cubes. So our biggest target, again, is plus 4 face center cubes. And because each cube has exactly 6 faces, we can just do 6 cubes times 4 equals 24 to crank out that extra 24. So that gives us 4 internal cubes plus 6 face center cubes to give us 10 cubes in total to be removed. So our answer is C. How many of the following 4 statements are true? Number 1, exactly 2 of these statements are false. Number 2, this statement is true. Number 3, statement 2 is true. Number 4, statements 1, 2, and 3 are all false. So this question, we realize that both statement 2 and 3 talk about the truth value of statement 2, which means we should analyze this connection first. Note that if both of these were true, we would create an unsolvable paradox with statement 1. So we will mark both of these as false. If these two are both false, statement 1 must be false. Because if it was true, exactly 2 statements would be false, 2 and 3, means statement 4 would have to be true. But statement 4 says 1 is false, that contradiction. Then statement 4 is proven as true. And because there is only one statement, statement 4, that is true, our answer is B1. Anika wants to arrange the numbers 1, 2, 3, 4, and 5 into a row. The last number must be odd. Also, for any 3 consecutive numbers, their sum must be divisible by the first of these 3 numbers. How many such arrangements can she make? This question is pretty exhaustive because we have to go through all the logical pathways for divisibility rules, so I'm just going to write which arrangements work and we'll count them up. 4, 5, 3, 2, 1, 2, 3, 5, 4, 1, 2, 5, 1, 4, 3, 4, 3, 1, 2, 5, and 2, 1, 3, 4, 5. There are 5 arrangements she can make. There's no easy way to do this, so we just have to list all possible arrangements. Ethan wants to draw a pentagon ABCDE with diagonal AD. The drawing should satisfy EA equals ED, AB equals CD, and AD is parallel to BC. Also, angle AED equals angle ADC, and the ratio of the measure of angles EDA and angle BAD is 3 to 2. Unfortunately, his diagram is not very accurate. In an accurate diagram, what is the measure of angle DCB? First, we notice that EA equals ED, so this angle and this angle should be equal to each other. We also are given the ratio 3 to 2, so we can assign BAD to be 2x and EDA to be 3x. This means this is also 3x because it's isosceles. Then, based on sum of a triangle, this angle would be 180 minus 6x. We are also given that this trapezoid over here is an isosceles trapezoid. So because BAD is 2x, ADC should also be 2x. The problem states that AED equals ADC. So we can use the expression to write 180 minus 6x equals 2x. So x would equal 22.5 degrees. ADC equals 2x. So it has an angle of 45 degrees. Because ADC and DCB, what we're asked to find, is supplementary to each other, we know that DCB angle is equal to 180 minus 45, which is 135 degrees. Therefore, our answer is A, 135. Anna, Elsa, and their mother are playing a reasoning game. Their mother chooses one of the pieces of candy from the options shown. She tells Anna the pattern of the wrapper and tells Elsa the shape of the candy. Then she asks, "Do you know which piece of candy I chose?" Both Anna and Elsa answer no. She asks the same question a second time, and again, both answer no. When she asks a third time, both Anna and Elsa answer correctly at the same time. Which piece of candy did the mother choose? So let's list what type of candy each one is. So A is round and dotted. B is round and solid. C is a cane and it is striped. D is rectangular and is striped. And E is rectangular and is dotted. Okay. So in round one, when both of them said no, if Anna had had the solid pattern, she would instantly know that it was B because it was the only solid candy. Since she says no, we can eliminate B. If Elsa had the cane shape, she would instantly know it was C because it's the only cane. She said no, so we can also eliminate C. That leaves us with A, D, and E. Round two, both of them said no again. So the patterns for A and E are dotted, and D is the only one that's striped. If it was a striped one, Anna would have known immediately, so it is not D. That leaves us with A and E. And because Elsa said no, even though she knows that A is unique and had the round shape, we can eliminate A as well. And that leaves us with E. That is why our answer is E. I hope you enjoyed these video solutions. As you train for your next math competition, check out these other great resources now available on Amazon.